You guys like that? Today we're going to talk about boiling points and freezing points and how they're affected by electrolytes. Remember, an electrolyte is, electrolytes are any ionic compound that separate in water into their components. So we're going to look at three different electrolytes. We're going to look at, first, sodium chloride, then we're going to look at calcium chloride, then we're going to look at aluminum chloride. So, when you look at your periodic table, you're going to notice that sodium is in group 1, calcium is in group 2, and aluminum is way over here in group 13. You can't see it because it's on the other end over there. Doesn't matter. So what we're going to do is I'm going to draw out the formula. Now remember, when you're doing an ionic compound, you have to make sure that there's going to be a positive component and a negative component. So we're going to go ahead, we're going to draw Na, we're going to draw Cl. Now we have to put the charges on there. So sodium, if we look, it's in group 1. It has a +1 charge. Chlorine is in group 17. It always has a -1 charge when it's in an ionic compound. So I'm going to go ahead and put a Cl minus, Cl minus. Now calcium and aluminum are in, this one is in group 2, this one's in group 13. Calcium is going to have a +2, aluminum will have a +3. Okay, so what we're going to do, we're going to figure out the formula for calcium chloride. That's +2, that's -1. They both go into 2. So this has to be negative, this has to be positive. To get from 2 to 2, multiply by 1. To get from 1 to 2, multiply by 2. So the formula for calcium chloride is CaCl2. The formula for sodium chloride is NaCl, 1 to 1. Now looking at aluminum, for every 1 aluminum, you need 3 chlorines. So aluminum chloride is going to be AlCl3. Okay, that's good and all. But, what does that matter? Well, if we're trying to do something like melt the ice, we have the structure of water. Remember, water is going to be polar, so this is going to be slightly negative, and these are going to be slightly positive. But when we're talking about actually water forming into a crystal structure in the solid form, we're going to have water molecules. Each one of these represents a water molecule. So when water molecules orient themselves in a crystal format, it's going to be in the solid state. So when you put in sodium chloride, into an aqueous solution, remember I told you that the oxygens are going to hang around the positive sodium. Because the sodium is positively charged, the oxygens are negatively charged. The hydrogens, which are positive, are going to hang around the negative chlorines. So what does that mean? We have positive sodium and negative chlorine. It's going to be floating around this substance. Now, this sodium chloride is breaking apart these water molecules. And it's causing this to not be frozen. So it's basically breaking these apart and making them go from a solid into a liquid phase. So sodium chloride, there is 1 sodium, 1 chlorine. That is a total of 2 substances. Now, when we're dealing with calcium and aluminum, break that down. Calcium and aluminum. Calcium chloride, we have 1 calcium And how many chlorines do we have? We have one negative chloride and another negative chloride. This is a total of 3 substances. So that's 3 things that can get into the water and break it apart. So instead of the sodium chloride, which was 2, could get in there, it would only break it up a little bit. Calcium chloride is going to get in there and break it up even more. And finally, when you do aluminum chloride, you're going to have Al3+, then you're going to have Cl-, and again Cl-. That is 4 different things to break this apart. Now what does this mean? I know I'm erasing a lot of stuff, but this is going to mess up the boiling point and it's going to mess up the freezing point. In order for something, this is the liquid phase. In order for something to evaporate, what needs to happen is these water molecules need to escape. So this is one water molecule, this is what it looks like when it's evaporated. It needs to escape into the atmosphere. If you put sodium chloride in there, it's going to mess up the boiling point. In fact, it's going to require more energy because these sodiums and these chlorines are going to be attached and it's going to basically hold this down. It's going to hold down these water molecules. So you need to increase the energy or increase the temperature in order to get these water molecules to float away. Because the sodium is holding on to the oxygen and the chlorines are holding on to the hydrogens. So it requires a lot of energy to shake this away into the gas phase. So the boiling point is increased. You will notice this as well if you boil fresh water from the tap and you boil salt water. The salt water is going to take longer to boil if you start it at the exact same time. Try it out at home. Now let's look at another example. The freezing point. In order for something to freeze, it needs to cool down enough in order to form a solid. But likewise, if you have something like a sodium ion and a chloride ion in the liquid phase, it's going to hold on to these water molecules, the liquid molecules, and it's going to keep them from organizing themselves into a solid. Likewise, the sodium and the chlorine are going to get in here and break this apart and cause it to go from a solid to a liquid. So to summarize, all this means is there's two different points. It's going to lower the freezing point and increase the boiling point. That's one. So it's going to change BP and FP. Boiling point, freezing point. Second thing, if ever asked, which one is going to affect it more? In other words, which one of these 3 will increase the boiling point more? You're going to look at how many substances they're made of. This has 1 positive ion and 3 negative ions. That's a total of 4 different ions. This one 1 positive, 2 negative, 3 ions. 1 positive, 1 negative, 2 ions. So to summarize, aluminum chloride is going to increase the boiling point more. So the other summary, more ions, more of a change. Practice, practice. Gracias. Guy, did that make sense to you?